In 2.5, we're looking at the quotient rule, or taking derivatives of functions that are defined as a function divided by another function, or f of x divided by g of x. So when we looked at this before, we used the box method, and we took the top function, f of x, divided by the bottom function, g of x, and found the derivative of each of these. And then, to come up with this rule that we have here, we started in the lower left-hand corner and multiplied the diagonal to get this first term. And then we multiplied the other diagonal to get the second term with a subtraction sign in between. And then we followed everything up with dividing by the bottom squared. So now that we're using regular functions instead of just function notation, we're going to have to take some more complicated derivatives to put in our box. So for this first example, the top function is 2. The bottom function is x cubed minus 1. To take the derivative of 2, we can think of this as 2x to the 0, or we can remember that the derivative of a constant is 0. The derivative of x cubed is 3x squared, and the derivative of 1 is 0. So then we're going to go ahead and multiply our first diagonal. So we're going to say y prime of x, or y prime, we can write the of x if we want to, is 0 times x cubed minus 1. Then we're going to subtract the other diagonal, and we're going to do 2 times 3x squared. And that's all going to get divided by the original denominator, so the x cubed minus 1 squared. And then we're going to clean this up a little bit. So the first term is going to go away because 0 times anything is still 0. Then I've got a minus sign and 2 times 3, so I've got minus 6x squared over x cubed minus 1 squared. Most of the time with quotient rule, when you're cleaning things up, you're probably not going to touch the denominator. You're most likely going to be simplifying the numerator. So let's try the next one. For the next one, I'm going to set up my box. The numerator goes in the upper left corner. Denominator goes in the upper right. The derivative of x squared plus 4 is 2x plus 0. The derivative of 3x is 3, and the derivative of 5 is 0. So then I'm going to start with my first diagonal, lower left to upper right, and I'm going to write f prime of x equals 2x times 3x minus 5. Then I'm going to subtract. I'm going to do the other diagonal. So that's going to be x squared plus 4 times 3, all divided by the original denominator squared. I am going to clean up that numerator, so I'm going to expand first. I'm going to distribute this 2x into the first set of parentheses. So that's going to give me 6x squared minus 10x. For the second set of parentheses, I've kind of got double duty here because I'm going to distribute the minus sign, and I'm also going to distribute the 3. So I'm distributing a negative 3 essentially. So that's going to get me negative 3x squared minus 12. And I'm going to divide that by 3x minus 5 squared. Notice I'm not expanding the bottom. And then in the top, I look for my like terms. So I've got 6x squared minus 3x squared. So that's 3x squared. Then I've got a minus 10x and minus 12. I look to see if maybe that factors, but it's not necessary. and most of the time it won't. Let me make that a 5. And then don't forget that denominator squared. Okay, so notice what I'm doing is I'm expanding the top and then simplifying it. I'm leaving the denominator alone. Let's try a function that's a little bit longer. So I'm going to put my box down here because it's going to take up a little bit more room. So I have 5x cubed minus 3x plus 2 in my numerator, and I have 6x plus 7 in my denominator. As I take my derivatives, 5x cubed, I'm going to do 5 times 3 is 15, reduce my exponent by 1, and then the derivative of minus 3x is minus 3. The derivative of 2 is 0. Then the derivative of 6x is 6. The derivative of 7 is also 0. So I'm going to say g prime of x, and I'm going to start with lower left to upper right, so my yellow diagonal, and I'm going to do 15x squared minus 3 and 6x plus 7. Then I'm going to subtract, and I'm going to do the other diagonal. So that's going to have 6 times 5x cubed minus 3x plus 2. And I switch the order on those on purpose because it is multiplication, so you can switch the order if you want to. And I'm going to divide by my original denominator, 6x plus 7 squared. So in expanding the second piece of this, all I have to do is distribute the 6. For the first piece, because both of those have 2 terms, I'm going to go ahead and do a box. So I'll do that off to the corner here. So I'll do a little multiplication box and put 15x cubed minus 3, 6x plus 7. 15 times 6, I got to think about that one. So 15 times 6 should be 90. X to the 4th. Then I've got negative 18x. This should be 15 times 7, so if 90 was 15 times 6, that's 105. X cubed minus 21. So as I write this out, I'm going to start with the 90 x to the 4th. Then I'm going to do plus 105 x cubed minus 18x minus 21. Not sure where that line came from. Then I'm distributing the negative 6. So I'm going to do negative 30x to the 3rd plus 18x minus 12. Still all divided by 6x plus 7 squared. And then combining like terms, the 90x to the 4th doesn't have a like term. I do have x cubes. So that's going to be plus, let's see, minus 30 is 75x cubed. The 18x's cancel out. And then I've got minus 21 minus 12, so minus 33. Divided by 6x plus 7. Hopefully I haven't messed up any of my arithmetic on that one. Okay. So I'm going to go ahead and erase this multiplication box over here so that I have room to do the next one. Because for the next one, when I set up my box, sine of x goes in the upper left, 4x squared plus x goes in the upper right. The derivative of sine is cosine of x. The derivative of 4x squared is 8x. The derivative of x is 1. So then I'm going to say h prime of x equals, I'll do the first diagonal, so cosine times the upper right-hand corner. So that's going to be 4x squared plus x times cosine of x. Okay, and I put the x's in front on purpose because otherwise it gets a little ambiguous as to what we're taking the cosine of. So cosine should usually go last. And then I'm going to do the other diagonal. And that's going to give me minus 8x plus 1 sine of x all over 4x squared plus x, quantity squared. And the nice thing about when there's trig involved is you're not going to end up with like terms that you can combine, so we can just leave our answer like that. For the next two, what we're going to do is start to layer in some of our derivative rules. So what we did on the page before is we did some trig rules and power rule and constant multiple rule with our quotient rule. In this next example, we have 2x times a quotient. And so what we actually have here is we have product rule with quotient in it. So I'm going to start this problem off as a product rule. And I'm going to go ahead and write my box. We'll leave some space here. And put my 2x and then my quotient, x cubed plus 8 over 7x plus 1. And then we're going to take the derivative of both. So the derivative of 2x is 2. The derivative of the quotient is going to need quotient rule. So I'm going to do another box. And I'm going to do x cubed plus 8 and 7x plus 1. The derivative of x cubed is 3x squared. The derivative of 8 is 0. Then I'm going to go ahead and do the derivative of 7x, which is 7. The derivative of 1 is 0. And so putting this back together in my box up here, I'm going to go lower left-hand corner. So we'll say 3x squared times upper right-hand corner, 7x plus 1, minus, and then we'll do the other diagonal, which means we have 7 times x cubed plus 8 divided by the original denominator, 7x plus 1, squared. So for this one, this is just kind of an exercise in stretching our minds a little bit. So we're not going to simplify that quotient rule. We can if we want to, but we're not going to do it. I'm going to go ahead and write out my y prime. And a y prime, I'm going to start in the lower left-hand corner. So I'm going to do the green diagonal. And I'm going to do 2 times the quotient, x cubed plus 8 over 7x plus 1. Then I'm going to do a plus because I'm doing product rule. And I'm going to do the purple diagonal. And so that's going to give me 2x times, I could clean this up now if I wanted to. I could make this 21x to the third plus 3x squared minus 7x cubed minus 56 all over 7x plus 1 squared. I don't have to divide by anything because remember, ultimately I was doing the product rule. I already did the quotient in the lower right-hand corner of my main box. Okay. And it's okay to leave it this way. There are ways to clean it up. We could factor out a 2, for example, but I could just leave this as 2x cubed plus 8 over 7x plus 1. And then there's my 2x. In that numerator, I do have a couple of x cubes, so I can make that 14x cubed plus 3x squared minus 56 over 7x plus 1 squared. Okay, but leaving it in the first format is just fine. And then we get to the next one. So with this one, I see the division. So I see the quotient. There's nothing multiplied by the quotient, it's just the quotient. So I'm going to start this as a quotient rule problem. And then see if I have to layer anything in. So I'm going to go ahead and set up my box and put 3x squared cosine of x in the upper left-hand corner and 5x plus 3 in the upper right. Well, 5x plus 3 is pretty simple derivative, so we can take 5x, the derivative is 5, the derivative of 3 is 0. However, the box in the upper left has 2 x's in it, and those 2 x's are getting multiplied together. So this is a quotient with product. So kind of the opposite of what we did with the other one. We did a product with quotient, now we're doing a quotient with product. So to find this box, I'm going to do another box with 3x squared and cosine of x. 3x squared, the derivative is 6x. Derivative of cosine is negative sine of x. So I'm going to do 6x times cosine of x. So I'll write that over here, 6x cosine of x. And this is a product rule, so I'm going to do plus. And then I'm going to do the other diagonal, which has a negative sign, so I'm going to be a little clever here, and I'm going to say minus 3x squared sine of x. And then I'm going to put together my quotient rule. So I'm going to start with that product rule that I just did and do this green diagonal. So y prime equals, and I'm going to say 6x cosine of x minus 3x squared sine of x times 5x plus 3. Then I'm going to subtract the other diagonal that I just highlighted in purple. So I'm doing minus 5 times 3x squared cosine of x, all divided by the original denominator, 5x plus 3 squared. And I'm sure that there are ways that we could simplify this. Like in that second term after the minus sign, we could make that minus 15x squared cosine of x. But I think, the point's been made. We can layer in some of these derivative rules and do multiple boxes.